like drumming, not guitar today, Greg.
Or car noise.
Yeah, wind, I guess.
I thought I was muted. No, it's just a fan. It's summertime here. So.
Hey,
Oh, hey, good morning, everyone.
Good morning.
So, I wanted to talk today a bit about Omega Hive and the sort of experiment of creating Omega Claw plus Open Claw agent hives and what it could mean as both a useful tool for building toward AGI and for actually perhaps a seed system that we can grow into an AGI. And sadly, Opus 4.8 is being slow at printing out my slide deck. Hold on, it's I think no, I see it now. I just I I had a version last night, but tried to add some things this morning. So yeah, as a side comment, as many others might have noticed, like the Fable model is just ridiculously smart. Like this is like GPT 5.5 Pro had been my sort of a hero among LLMs, although very slow. I feel it had been dumbed down a bit in the last month, which is one of the annoying aspects of these big tech models. Not dumbed down that much, but now Fable is significantly cleverer at math or programming than GPT 5.5 Pro was at its peak, I would say. I mean, it's ridiculously expensive, so you would bankrupt yourself using it, using it for everything, and using it judiciously is one thing that's going into my experiments with agent hives. But yeah, I would say, I mean, I think the safety hype is a bit bogus, like except for computer hacking, which is well known and much discussed, and it's disabled from doing. Like I don't see any way to use a model of this class to destroy the world, right? Like I mean, if I wanted to learn how to make a bomb or a bioweapon, I could do it anyway without that model because these are not immense intellectual achievements. Actually, they're just like scarfing together information off the internet. So I don't feel like nefarious plots are gated by IQ of your advisor. Actually, they're they're gated by other factors. I mean, again, computers like cybersecurity hacking being an exception that's much discussed. I have found that the security restrictions are weird. Like it kept giving me security restrictions and trying to fix the bugs in my attempted proof of p not equal to np or something, right? And then I found like if you start a new session and rephrase your query, then it becomes not a security risk, and it also has a demented psychology like all the Claude models. So like if you ask it too hard, something too hard, it will tell you it's impossible. You have to go like, suppose a supermind had solved this problem. What would be the 5 options you think the supermind had followed in solving this hard problem? So I mean, it's certainly not an AGI with self-awareness and self-understanding and all the bells and whistles you want. from a mind, but it does feel like a significant leap in problem solving tool. And I mean, we've seen a series of similar significant leaps in the history of LLMs. So I mean, it's probably not as big a leap as from GPT-2 to 3.5 or something, but it's still significant. Another interesting, by the way, comment, there was a paper on Anthropic's site, which I don't think I sent a link on Mattermost to, maybe I did, or someone did, but sort of showing that the latest Claude models show an emergent global workspace, which is quite interesting. So that it's just like a subset of the activation space, which collects information and propagates information in the manner of a global workspace, and which also is what Claude calls on when you ask it what it's thinking about. It's the things of the highest activity in this global workspace. Now, it's not a full-on attentional focus with all the aspects of a global workspace or a working memory, but I mean it is actually, assuming they're not lying, it actually is an emergent working memory of a primitive form, which is quite interesting, right? And I mean, I think again, none of this means that's necessarily on the route to a full-on human level AGI. It's still a lot of capability built on a weird sort of foundation because its basic reasoning and pattern recognition ability, they're not tied in with self-modeling and self-understanding and world modeling and world understanding. And they're based still on this overly enumeration of special case-based knowledge representation, even though there's some emergent abstraction in there as well. So it's still a weird construct, but it's a very functional weird construct. I mean that line of thinking leads in a few directions. I mean, one of which is Omega Hive that I'm about to jump into, having stalled long enough that Claude finished producing my presentation. So the I mean one direction that leads to is a project I may talk about in another one of these meetings, which is trying to train a predictive and causal coding residual layer on top of large open models, because I think GLM 5.2 is also very smart. It's not as smart as Fable, but I mean, the pre-trained model is very good. It's as good at Fable as doing some things, not as good at doing some things that interest me most, like doing math proofs, right? But equally good at many, many things. And it seems plausible by training the right sort of layer on top of that, you can make it even smarter than Fable, leveraging the huge pre-trained model that's basically all the knowledge of the internet. At least that's the kind of experiment nobody has run, because it's not just fine-tuning. You're talking about training, like train a 20 billion parameter model network on top of a trillion parameter network, but do it with a special, more cognitive structure to that smaller network, right? And I mean, it would be quite interesting geopolitically to get a big breakthrough by training our own open model on top of an open Chinese model, right? Because the next natural step would be to go to Jipu and collaborate with putting our training mechanism into GLM6 or something. So that's one interesting direction. Another interesting direction, which I want to turn to now, is, how do we leverage these very smart but only partially AGI-ish models? How do we leverage these to accelerate our own progress toward AGI, and maybe toward AGI systems that leverage LLMs, probably hacked open LLMs, but to some extent the proprietary LLMs also? Like, how do we use these increasingly smart LLMs to help drive our progress toward actual AGIs that leverage these LLMs along with other things? Let me find my presentation. Oh, here we go. Yeah. Hold on a moment. All right, here we go. Yeah, so view. How about that? No, no, that's not what I'm. Oh, hold on. I'm fighting with Google Slides here in an annoying way. No, it got rid of my menu. All right, that's not perfect, but I will do it this way. Do the incompetence to figure out Google Slides. So what I want to talk about is first some experimentation I've been doing already with a hive of OpenClaw and OmegaClaw agents, just trying to automate some of the research stuff I do in my spare time. And then mostly a slightly bigger architecture for bringing these multiple agents together in a productive way. So the smaller agent hive I've been playing with so far, the centerpiece is an OpenClaw research agent, which I constructed fairly carefully from a shitload of other people's skills, including skills at running code, but also a bunch of memory skills and so forth. So trying to piece together existing skills to make an OmegaClaw agent as useful as possible for helping with research. And among those are skills for creating subagents. So I mean, one of the things I found is if you try to get the same OpenClaw agent to do a bunch of different research tasks, it gets confused and doesn't manage it very well. So what you have it do is when you have a research task you want to do, you have it create a subagent and just run that subagent on like a cron job that goes over and over again and just keeps pursuing that task. Then there are Kanban board, like Trello board plugins, and you just get it to keep track of everything it did on that Kanban board, and then it keeps track of all the subagents, and that works all right. Then it tends to lose track of everything it had installed and all the changes it made to itself, but you can get it to construct basically a JSON file, which is just a memory of all the everything it's installed and what its purpose was, right? So using specific memory tools like a Kanban board and just its own little database of everything it's installed and why, and you can make it consult that memory in its core loop as it manages its subagents and all that has no OmegaClaw. That's just setting up OpenClaw as a research agent, and it works pretty well. I mean, it's then I set it up to use GLM 5.2 for routine chats back and forth, and GPT 5.5 for most things, and then each project gets periodic strategic reviews using 5.5 Pro or now Fable. So like once a day, each subagent consults a really smart model and asks for like a strategic review of progress. Then I found GLM still is not as smart as 5.5 for research tasks, but for chit chat back and forth, it's fine. And some hacking had to go into vibe hacking, like how it balances between these different models. It took a while to get that right, which is still, it works, but it's to some extent a work in progress. Now, but the big use I found for OmegaClaw here is So first of all, I used an Omega Claw hack called Threadkeeper, made by Larry Greenblatt in the Omega Claw Hackathon, which lets Omega Claw make sub-agents also. And that's still a work in progress. I'll push that pull request at some point when it's working a little better. But you can have an Omega Claw with sub-agents. It's also helpful for the same reason as it's helpful for OpenClaw. The main use I found is just Omega Claw, at least this particular instance, has a bit more insight. So what I mean, I have trained this Omega Claw instance to use my hyperseed ontology obsessively about everything. So like its main prompt is whenever you get something to understand, semi-formalize it in terms of the hyperseed ontology and then think about it that way. So I'm not doing any like lean-based formalization yet. I'm I mean that I will, but on the other hand, that's expensive, and you won't want to do it all the time either, right? And you often don't need it. But it was more just to give the agent a certain systematic point of view, and then for each project the sub agent is doing, as well as a review from 5.5 Pro or Fable each day. I have a conversation between the Omega Claw and OpenClaw agent on the project each day, where they go back and forth in a bit of a chat each day, and that has two functions. I find just having the OpenClaw agent formalize what it's doing in a verbal way to say to another agent on a chat, even when I don't have time to listen to it, like that summary process often exposes things that it didn't see otherwise. But then also the Omega Claw agent has a different perspective. Like it does seem to build up a coherent conceptual model of the world in a way that the OpenClaw agent doesn't because of the nature of its memory. And that, I mean, I haven't tried to measure or quantify that, but qualitatively it seems to be the case. I mean, a formal study of this would compare the same architecture with a different one where it's just two OpenClaw agents chatting about the thing then you would measure how much plus there was from having the Omega Claw agent as the chat partner, right? But qualitatively, I'm quite confident there's a plus there because I can see from my own chat with these agents about projects I'm doing, I do get different insights from the Omega Claw agent than from the OpenClaw guy because the OpenClaw guy just he's very good at doing stuff because of all the skills, but it forgets what it loses the thread way more than the Omega Claw loses the thread just qualitatively from a user standpoint. So I started playing with this just to see what I could learn from the experiment, and it actually has been a decent way to get research coding done also. I mean, to make clear what are the limits, like I'm not trying to do production coding, right? And I'm not good at it even myself without any of these agents. So I'm trying more to automate stuff that I already am fairly good at doing, which is fleshing out ideas by making research prototypes and running them, seeing the results, and then writing it up, feeding back to do more prototype coding to get more ideas. Now I don't I strongly suspect a similar methodology could be very useful for production coding. There will be differences, and that's best fleshed out by people who are good at doing that themselves, which I'm not so much, right? So that's about the experimentation I've been doing. Now I designed a broader architecture, which would have more different agents serving more different roles, all cooperating together. And I put a bunch of thought into that and then realized, as often happens with my ideas, it will be more work to build than I had originally planned on. Now my current agent MiniHive is very eager to build this architecture. And I mean, it created the 1.1 spec for the architecture by improving my 1.0 spec for the architecture based on lessons learned in playing with this initial sort of proto-hive. But instead, Casio and some of the Questor team are working on building the infrastructure to get this hive working the way that I would like, and or some approximation of the way I would like it. Well, given that this sort of system is good at improving and upgrading itself, I mean, whatever is created initially will not last long, and the system will keep improving itself, right? But the the connection with my initial rambling on how clever the Fable model is, I mean, you get the feeling that by wrapping something like Fable in this kind of agentic architecture, along with PLN, running on a intermediate scale memory atom space, like this will get closer to AGI than just Fable. And I feel like this whole architecture I couldn't have done usefully before GPT 5.5. Like, I think GPT 5 would have been too stupid to make it work. And just like GLM 5.2 was still too stupid to make it really work at the level that I'm playing with it now. So we're now how well this will work when a Fable class model is cheaper and can be used routinely like GPT 5.5 can now isn't clear, right? Like, so it could be that you'll have an architecture that's kind of a useful research assistant, and then when the LLM inside it is upgraded, like more emergent dynamic from the whole agent hive just pops out in some form. I mean that there's a lot we don't know, and that's just experimental. What I can say is I get the feeling that between LLM improvements, integration of more Hyperon tools, and this sort of multi-agent collaborative design, I get the feeling this is one way that some genuine AGI system could pop out, right? And it's of course, that's an intuition rather than a rigorous conclusion. But I mean, I have been working on AGI a long time and haven't expressed this sort of intuition ever before. I don't think and like I said, playing with Fable, it seems super clever, but you can see like its self model is fucked. Its ability to control itself is fucked. Like there are key things there that will make that system never become a human level AGI, and that's not so clear when you start embedding these models in this hive type architecture. Like I think you can do way better by training a more symbolic friendly residual layer on top of an LLM. Whether you need to do that or not, I'm not sure. But let me roll through this presentation on Omega Hive and the overall architecture we're talking about here. So to position this at the very high level, like there's a lot of pieces you need to build an AGI, right? And so this is not like a scientific list of all of them, but it's a qualitative list of some of the things you need to think about. I mean, we think about AI algorithms, and that's taken a lot of time for most of us who've been in the field a long time because it's interesting, math and computery stuff to think about. Knowledge representations, and this is a lot of where I think transformers fall flat. Like they're very smart, but the knowledge representation is still too special case enumeration-ish. They work around that in an interesting way, but I think for really radical creativity, you're going to need more of an abstract representation than what they have. Cognitive architecture, which has existed a long time in the AI field, but is out of fashion now. There's control dynamics. I mean, PLN inference control is one aspect, ECAN is another aspect. There are many, many other aspects. Emergent dynamical patterns in the system, which I've talked about since forever. you need a large system doing complex things to see them pop out. The apparent emergence of a sort of global workspace in large transformers recently, as Anthropic has pointed out, is a very interesting example of an emergent dynamical pattern. I also have some specific work going on aimed at identifying and fostering emergent dynamical patterns in agent hives, which I'll talk about in half an hour or something at the end of this presentation. Then there's what does the system do? What's the education and experience? And this Omega Hive experiment focuses on 3 through 6. I'm not trying to innovate in this particular case in algorithms or representations. I've spent most of my career trying to innovate in algorithms and representations. So we have quite a lot of innovations there in the queue to be rolled out into this framework. And of course, we're heavily leveraging transformers, which is largely an algorithm plus architecture innovation. So I'm aimed at 3 things here, and to say Opus 4.8 is very nice at making presentations. I haven't wasted Fable credits on the deck, but I think the quality of decks has improved a lot in the last 3 months. I mean, I'm trying to make a real research assistant. I'm just trying to learn about agent hives, and I'm wondering if this can actually be a seed for AGI. And the overall architecture, it's not just like 10 agents all interacting with each other. There's a small number of persistent agents with defined roles, and they're spawning a dynamic hive of worker agents that can be persistent. They could last days or weeks, but they could come and go. And I think that combination is the right way to do it. And there's a bunch of principles you can identify in trying to make this work. And a lot of this comes from other people's prior work with OpenClaw and Omega Claw. I mean, initially I tried to have a smaller number of fixed workers, but I saw just using dynamic subagents was very, very important. And then constructing a memory of a bunch of different specialized stores all working together is very important. And the prompts are important, but less important than one thinks initially. And this was found with Omega Claw also, because the prompt just sort of seeds the system's interaction. And then this sort of system keeps making changes to itself based on its discussion with you. So as long as the prompt is kind of in the right direction, it will lead to an interaction dynamic that leads the overall system, into a good place. And with Omega Claw, that can be stronger because it can be self-modifying it in a stronger sense than OpenClaw. But an OpenClaw system, because it can create its own skills and it can create its own custom databases and so forth. I mean, even though the core loop is not modifying its code, that the whole armamentarium it's using is still self-modifying with a fixed core loop. And that's the level of self-modification I've used so far anyway on either the Omega or OpenClaw side. Although one project I'm trying to get the Hive to work on is building an intermediate scale memory atom space in PETA, for which I'm using Mesto's gold chainer. And so once that works, assuming it works, then that'll be Omega Claw figuring out how to upgrade Omega Claw, right? By plugging in the intermediate scale memory with some simple OpenPSI system and goal-driven chaining and so forth. But so far, I haven't gotten there, and the self-modification in the system has just been at the level of having the system build new skills and new memory stores and new communication channels rather than changing the basic loop of the system. So some of the mechanisms in this Hive design. We have some Omega clause, we have some open clause, and I think we can get rid of the open clause within probably a few months. I mean, I posted a document on hardening Omega Claw, which listed some of the things that are right now worse about Omega Claw than Open Claw as just a practical software system. I mean, just qualitatively, the Omega Claw instances I've run into more issues, and I asked the Open Claw instance to fix them, right? And if I didn't have the Open Claw there to keep tweaking Omega Claw, I would have to do it myself, which would be annoying. But I mean, there's no big cosmic thing that Omega Claw doesn't have. It's just a whole bunch of hardening as a software infrastructure. And we have competent people working on that now. This kind of thing just takes a little bit of time. On the other hand, if you're carrying out a sort of fixed set of repetitive tasks, it might be that using an Omega Claw doesn't help that much either. I mean, maybe it does. That's just an experimental question, right? And then we have some agents in the persistent core, some agents that are like spawn sub-agents. We need to keep track of what all the agents are doing. So you have a task graph of tasks, subtasks with dependencies, which is part of the shared memory of the whole Hive. You need an asynchronous task queue. One thing I have in a very simple form in my current setup, but needs to be more complex when you have all these agents. I mean, I have the agents talking back and forth on Telegram channels when I want to talk to them and see what they're saying. But in the end, they can talk back and forth much more than I will have patience to read, and using Telegram is inefficient. So I have the Omega Claw and Open Claw agents just chatting back and forth. I mean, they're sitting in the same Linux box in my house, right? So I mean, they're all sitting in here in this System 76, like Pop OS Linux box. I've taken all my old laptops and connected them with Tailscale to make like a little computing network in my study. There was a lot of wasted processing power before because I didn't need all these old machines. But old machines are fine for running these agentic loops and putting any ML processing out onto clouds, right? So I think having a fast bus for communication among different agents is valuable. It should all be logged, of course, so a person can look at it if they want to, but then the models just have to make some judgments as to what communications go into fast bus and what go on channels where humans can read, like Telegram or Slack. On the other hand, you can make some fairly clear, rigid rules when then there's only a few borderline cases to govern what goes on the bus and what goes in the human legible layer. And then you can give a list of practices that are just in a file that are obeyed by everyone. Like don't try to hack out of your container and so forth. So
Hey Ben,
uh-huh.
yeah, just before you move on, one thing I want to note is as I'm trying to build the actual architecture for this, task graph, task queue, and the bus are just the same thing. They are an append-only event log that the agents use. The graph of tasks that you can turn into a Kanban board or the status of tasks, all of that you can just derive from an append-only event log, which is the fast bus for the agents to talk to.
That's
That
interesting.
means you always have a single source of truth for the state of your Hive, instead of having a log of agent communications that may or may not accurately trace the status of your Kanban board and things like that. Everything is derived from a single nice append-only thing that no one can rewrite.
That's a much better architecture. Yeah. I mean, what I have now is a hack where I just have three different structures for these that the OpenClaw agent built. But yeah, what you just described is a much nicer way of doing this stuff, definitely. And yeah, it makes sense.
If you don't mind, I will also just quickly comment here. We experimented with different event-driven buses. So in the architecture, we experimented the task scope and the task graph is separated from the event-driven bus in the agentic workflows, and that works really well when you have asynchronous event-driven bus, something like RabbitMS or different solution. It's just technical layer for asynchronous free really fast calls between the agentic systems and agents per se.
Yeah, there's a bunch of design decisions here I haven't thought about, and but what Cassio described makes logical sense. I mean, the task graph is just a small subset of this append-only graph, then, right? I mean, so
we'll just see order of the like couple of order of magnitude more events than tasks you can formalize. So
yeah.
That's directional layers. Yeah.
Certainly true. Yeah. So yeah, the agents are sort of, I mean, there's a template for agent configuration, and then there's memory associated with the agent. And I mean the memory plus the collection of skills is the main thing, right? And that, I mean, that's the crux of what makes the agent. And then I can run a great number of agents on a laptop because all intensive processing is just being outsourced. So there's an Olama model whose use is just if the connections to all the other models die, I want to be able to chat with the OpenClaw using the Olama model about how to fix the connections, right? But then like the serious processing is done either Open Router or other API calls directly, and any serious ML processing is also offloaded in other places. Of course, these could all be different containers on the same uber powerful machine if you had one. So I've discussed this already, but I mean you can go in detail into what does a sub agent need to do and what does a persistent core agent need to do, and systematizing this is important, or you'll have a lot of sub agents doing random silly things. And this design is what Cassio just questioned. Like, actually, it could be one substrate, and that's also fine. In my current prototype, it's two substrates, but that wasn't based on any one principle. The append only thing is important. You want these things to be atomic so you don't duplicate execution, which happened to me in the early stages of playing with this hive many times. So that there's a bunch of details you can specify for each dispatch of a task, none of which is very surprising. Like what tools can it use? What file paths can it use? Are there limits to how much it can use this or that tool? What should the output look like, and so forth? So and the audit of what the agent did is also stored in this same append only store that Cassio has just described. The two buses I already described. The memory has been interesting here, and actually beyond what is on this slide, but it seems like most of the hacking I've had the prototype Hive do to make itself function less badly has been about different ways of remembering what's going on. And that the Omega Claw's memory has been useful conceptually for like building a accumulating knowledge base of like what's the meaning across all the different tasks I'm doing, which are all related to each other. But then things like a Kanban board or a database of what's been installed and so forth is equally useful in terms of the overall system function and then file system organization, because the system will store a lot of documents, and then search is always a problem. So it will store a lot of documents and forget what documents is written or forget what documents it is stored unless you have told it to index them in some nice way. And there's a couple OpenClaw skills for embedding based semantic search which are useful, but you can see as these things get bigger and bigger, using Hyperon functionality to help search long-term memory of documents, transcripts, and knowledge and so forth is helpful. I haven't done this yet, but clearly installing Diane Krause's Scout application for my own search of all my own chats with these agents would also be valuable, because finding stuff in the chat history with agents is very annoying, because I mean I'm using Telegram, and Telegram's chat search functionality isn't great, but it's better than like ChatGPT or Claude's search functionality for your history of interaction with them, actually. So some obvious things. I mean, you record everything. It gives a search problem, but you still want to record everything, and you can then give explicit instructions to take care of not hallucinating stuff, and take care that there's evidence for every claim make and so forth. And indeed, every subagent has to have explicit instructions for this. Otherwise, the LLM will make a bunch of shit up and take a bunch of stupid shortcuts. But on the other hand, having part of the mandate to the subagent be to not do that does pretty much it does pretty much work. So having a lot of tedious structured processes like would drive human employees crazy works very well with this sort of system. So I mean, you can have a structured process where a subagent proposes something to do, then the control agent and its Omega Claw advisor discuss what to do, then the subagent can do something only once it's gotten that approval, right? And I'm using a simplistic version of that process now, but it's not hard to do the same thing when there's more agents that are involved. And even with my simplistic system, I tried to set it up in a way that some rogue agent wasn't going to wipe the drive of my laptop. I put all this on a bunch of old laptops that had nothing else running on them. So like the worst case is not very bad, but still, it's not that hard to set it up appropriately. I mean, I had two colleagues who I think are on this call had Claude Code wipe out their hard drive or most of it at some point. So I've tried to set things up to avoid that sort of outcome, and have succeeded so far. I would say, since playing with this setup, I stopped using Claude Code or Codex, because those loops are just much stupider than this OpenClaw plus Omega Claw loop. And if you don't provide them constant guidance, they go down stupid rabbit holes and go awry too rapidly. Whereas even my prototype version of this framework has much less of that characteristic. So one one significant aspect is model choice, but I already sort of described that. I'm right now using 4 layers, I guess. There's like a local Olama that's almost never used unless everything else has died for some reason. There's GLM 5.2, which is used for routine chat, and I had to hack the prompt to that to get it not to write in such an annoying way. But you can sort of hack the prompt to make GLM write more like OpenAI with complete sentences and some structure to the paragraphs. Although by default it doesn't like to. I mean, I see for Max Botnick, we haven't bothered with that just for taste reasons, but you can make that model right in a less autistic way if you want to. Then there's Workhorse, which has been GPT 5.5, which does most things requiring intellect. Then there's the super expensive models that use for periodic review. But what I found is I use GLM as the router. Like I tried to have a very simple routing rule, but it fucked up too much. So you like basically, unless it's broken, you forward everything to GLM, then you let it think about where it should route it. And sometimes that can mean answer it itself. And then there's a bunch of annoying engineering there. Like GLM chokes on a big context. So you summarize the context, feed GLM the prompt with the summarized context, then let it decide whether to answer or route. If it routes, then the other models, like 5.5 or the expensive models, can deal with the full context, not just the summarized context GLM got. So there's some sculpting of how summarized of a context do you give to each model in the hierarchy, which I'm sure is not done optimally in my current prototype, but that aspect is super important because I mean the LLM is obviously in each run of the loop. I think I've been through this research loop already, which would be different if you're doing production engineering or something, but this is designed to help with the with with AI and math research. Now, something I don't have in my current prototype, and which is a little bit edgy or weird, is I want to have an agent that is sort of monitoring and modulating the psyche of the whole system, both meaning the psychological aspects of the individual agents and emergently of the entire thing. And this really has to do, in the most practical sense, it has to do with what are the attitudes of the various agents toward each other. Like, does the sub agent have too much hubris, or is a model being too wimpy and too afraid to make a big innovative leap? Like in all these cases, you can tweak this by hacking the prompt of the agent or other aspects to make it less sycophantic or make it less cowardly. And I think that those are the two aspects that have jumped to mind the most, but there are other values you may want to align. And then there's also the question of what's the emergent dynamic of the whole agent network. Like are certain agents somehow dominating the way things are stored in memory more so than others. So I think having an agent that's sort of at the high level monitoring the individual and emergent sort of psychological aspects of the whole network can be quite interesting. And if I had more time, I would say a lot more about that. But that is one of the things that sort of leads in the AGI direction. But I want to finish going through this. So here's a list of some key roles that I think will be interesting to start with from the standpoint of a research assistant hive. And this may quickly be refuted through experimenting with the actual hive, but I mean, these are all things that my prototype hive does, and I can see that the agent doing having the same OpenClaw agent try to do all these things causes more confusion than one would like. So in my current setup, in essence, the Omega Claw is being the research generalist theorist, and the OpenClaw is doing everything else. Now and then I have the Omega Claw build something also. So it's doing a little bit of that, but only in the last couple days since I started playing with Threadkeeper and Omega Claw subagents. So these are pretty self-evident. Process management, resource management, and psychological oversight, curating file systems and folders and memories, actually doing the research, and then communicating. And I think this is, again, something to be experimented with, but the way these agents communicate is often bad. Like they're not paying enough attention to how the communication is received, in which context, and which communications are actually useful versus annoying. And it seems like having an agent treat optimizing communication for utility and happiness of the human user like this I think can be a learning process on its own, and then you can get the communication to be less annoying. But that is like the psyche thing. That's another thing to be experimented with. And there's a bunch of plumbing you want here, some of which is what Cassio was talking about, and then a bunch of other plumbing also. So you don't want to leave everything to the level of intelligence, because the intelligence systems are not that reliable or that efficient, right? So there is some actual software architecture here as well as the cognitive architecture. And the way I think this should be done is different than how like Claude Code's agent hives are doing it, although those are certainly well sculpted for some purpose. Let's see, let me move ahead because I'm going to run out of time, and I want to get to the more AGI-ish bits. So yeah, I think that gave you the flavor of the architecture I'm hoping to have, and how I'm playing around that space with a simpler prototype. With the next few minutes, let me talk a bit about the possibility of using this to seed an AGI. Now, I mean, of course, if all I get out of this is a really cool research assistant that speeds up doing research even more than LLMs themselves do, that's already cool. Like, even if the system just helps me to build some totally different kind of AGI system together with all you guys. On the other hand, I think it's quite possible you could grow this sort of hive into an AGI, and that would be a combination of three things, right? It will be a combination of LLMs being smart, either in the vanilla form or hypothetically in some form that we improve with residual layers or predictive coding whole LLMs eventually or something. Hyperon tools being smart, and I mean, we have atom space in there and a bit of reasoning, but one thing I'm pushing on is getting an intermediate scale peta memory with some goal-driven PLN in it. And then, I mean, we can merge more and more Hyperon AI methods in there into this framework, because the Primus cognitive architecture has always been very, very flexible, and most of the tools created in that context can be plugged into this sort of context perfectly well. And then the third element is, emergent dynamics that pop up when you have all these agents working together on this sort of substrate. And to an extent, the Hive can improve itself. I mean, it can. One loop I have going is every day the OpenClaw and Omega agents reflect on what they did that day and what new skills or self-modifications they could make to make themselves work better the next day, right? And sometimes that means writing a new skill. Sometimes it means just downloading a skill. As things get smarter, I mean, it could mean inventing a new AI algorithm or something. So, I mean, self-improvement just based on every day asking, how can I make myself better using the tools available? That certainly is a thing, which is a very interesting thing. On the other hand, I'm also here, like we're also here. We have a whole bunch of thinking about how to make AGI. And so a lot of the use of this research assistant is doing research on how to turn the research assistant into a smarter and smarter mind, right? And so there's while it can improve itself, I think AGI R&D at this point, us plus the AIs is still better than just the AIs, right? And presumably that will be the case until we actually get to AGI. So you can see there's a bunch of mechanisms in this sort of hive that are complementary to and overlapping with the mechanisms in Hyperon, or in the Primus design, but not exactly the same, right? So like I mean, learning, there's an added aspect here, like you're learning what skills to plug in, then just download them and plug them in, right? And the memory, again, you can have an atom space of memory, and you can have a ChromaDB wrapped in an atom space of memory. But you can also have all these specialized working memory tools. And like you think human working memory has this like speech rehearsal buffer and a visual workspace and so forth. Like human working memory is a bunch of quite specialized things. So here we have a different collection of quite specialized things, which are more computer toolish, right? But it's similar at the high level in that you have a bunch of little specialized memory stores and loops whose dynamical interaction is comprising in practice the working memory, right? And in terms of attention, for example, I mean, I think you still want ECAN within atom spaces, and especially within an intermediate store memory atom space, which I think will be intermediate scale memory atom space beyond the small working memory and the huge long-term memory that Omega now has. I think that will be a key ingredient. But we can see, that routing of attention between these different LLMs, the dispatch of things among different sub-agents, the allocation of compute resources to the sub-agents, like who gets the run pod, right? I mean, this is all attention allocation also. That needs to be made interoperable and interconversant with the ECAN attention allocation within the atom spaces. And I mean, Greg Meredith's calculus of costs is certainly relevant here, and it provides a nice principled, like type theoretic way to think about all these different aspects of resource and attention management. So yeah, I had been thinking about, can you make Omega Claw sort of into the cognitive cycle of what used to be the cog server in Hyperon. And what I'm seeing now is with this sort of system, it's a different sort of cognitive cycle, right? Like you have multiple agents with their own cognitive cycle, then they're interacting, which leads to a sort of emergent semi-chaotic cognitive cycle of the whole system. So which I think is something Cassio said to me a month ago, like maybe the omega claw loop is the ingredient out of which the cognitive cycle is built. So this sort of instantiates and goes beyond that, right? Like it's multiple omega clause loops, and open clause loops are the ingredients out of which some emergent cognitive cycle is built. So a possible path to AGI we have here is get a bunch of hives like this working, and maybe many of them. Maybe I have my hive, and each person on this call has their own. They're all talking to each other. Part of what they're doing is learning together with us how to improve their own cognition. And this is one way to get to a Hyperon seeded AGI. Now, the last point I want to go over is another research project I'm playing with, is trying to understand the dynamics of this sort of system. So I have a simulation of Omega Claw running, which is a sort of nonlinear dynamics simulation. And what I'm playing with there is seeing how do you get this simulated Omega Claw system into interesting chaotic dynamical modes, and then looking at the strange attractors of the dynamical system, and then the structure of the multi-lobe strange attractor of the system, and what is the emergent grammar of the transitions between the different parts of the structured strange attractor of the system. And this this is stuff I've done research on for decades, is like how do you use AI methods to understand the structure of the strange attractor of a dynamical system. My hypothesis here has been that effective modes of emergent function in this kind of hive will correspond to structured strange attractors of system dynamics. And this goes beyond what I can talk about in depth in the next 2 minutes or so, but it has to do a lot with the different time scales on which different agents are operating, and delays between one agent saying something and another agent reacting, and that leads to quite complex behaviors. So I have a new implementation of something I came up with in the mid 90s called the chaos language algorithm, which is a way of using grammar induction to infer the structure of a strange attractor. And one of the things I've had this agent hive doing, we re-implemented this. We've shown that it works on a bunch of higher dimensional dynamical systems out of the dynamical systems literature, and we're now playing with it on a simulation of Omega Hive. So if that's sort of a speculation on top of a speculation, but I mean, if that works, then I mean, what that gives you is an interesting way for the whole thing to kind of self-regulate and self-understand. Because if the grammar of a systemic attractor is the right way to think about like an overall state of mind of the agent hive, then that would feed into the psyche agent and would become quite interesting. But how that pans out in terms of the actual agents remains to be seen. So I've got maybe 10 more minutes before I have to shift into dad mode. But I think I finished what I wanted to talk about here, and this has been a great amount of fun. So I'm quite grateful to Patrick Hammer especially, but everyone else who has been building the tools that have plugged into this framework, which has been very, very interesting to play with. But I'm also very glad to have a team working on building out this more robust architecture, because I can see getting there incrementally by having my current prototype hive patch itself would be a longer haul than having a nicer infrastructure just built and then porting the cognitive content and memory of these proto agents into the new hive. And I would encourage everyone to try their own similar experiments if you're not already. It's a challenge to find time to screw with all these new tools, which are coming out at such a feverish pace when there's so much other work to do. But I mean, it actually does seem not only cool but worthwhile. Like we are at the stage where we're definitely at the stage where the latest tools actually can accelerate the work we're doing in a useful way if used intelligently, which is not always easy. And we're even just barely at the stage where our own tools are interesting as part of the mix of the tool set that accelerates our work.
And it also seems to be the case that it more boils down to finding the right ways to let sub-agents or agents in the hive communicate, and also to have potentially shared atom spaces and shared memory across the agents. And so that now there's a architectural challenge ahead, which is to find the right structure for this to happen effectively.
Yeah. The shared intermediate timescale memory will be very, very key, right? Like I think
Mhm.
working memory should be largely per agent because like each agent is doing its own thing, and we sort of have a good prototype for that in the current Omega Claw. I mean, it needs more, but it's we sort of see how that can work. And the long-term memory of the whole thing, I mean, the ChromaDB wrapped in atom space is a first pass. We can build a bunch of other indices on that memory, right? But we sort of can think about clearly how to make different indices into the long-term memory of the whole thing. And then when it gets too big, you put it into distributed atom spaces and other distributed stores. But the sort of intermediate time scale memory atom space that all the different agents are collaborating on is important, right? Because the different agents are doing different but related things, and they should be cognizant of what each other are doing. And then you want an agent who's sort of making connections and fleshing out the abstractions in that shared memory for the common use of all the agents, right? And that I've seen that is the key thing. That's why I'm trying to get an intermediate scale memory using PETA to work, and I've been drawing on the Mesto's stuff with his version of the goal chainer there, but we rapidly will need moderately scalable inference control to make that function so that which I mean it's a use case for the geodesic inference control that you're working on, right? Because you clearly need forward chaining, just combining what's there, and you also have goal directed backward chaining, which is what the goal chainer structures, and you need both of those, and you need them to connect. I mean, of course you could do that without a formal geodesic chainer. You could do that just by writing a forward chaining loop and let it go, and by having backward chaining from the goals and just have them both acting on the same atom space, and they will connect through having the same shared atom space. But I think the geodesic chainer can make it more efficient for those two ends of inference to connect.
Mm-hmm. I agree. And it could potentially also be allowed to have like a flexible way to re-encode some of the knowledge, because if we have with Omega Claw, if some knowledge is verbally represented, then maybe we also can give the agent the freedom to re-encode some knowledge, so that in the geodesic inference control there might be cases where some knowledge is not yet encoded, but if it's encoded, the inference can proceed and find a formal.
Yeah, so I'm experimenting with that on a sort of atom space structure level or aiming to by having an Omega Claw agent obsessively interpret everything in terms of the hyperseed ontology. So then if you do that, you have a specific menu of a couple hundred concepts, and you have an agent whose job is just to link everything that comes in into those couple hundred concepts, right? And that gives a particular structure to the Atom space, which should have an implication for what the chainers are doing, because you're going to have a couple hundred nodes that are a few links away from everything, right? And I mean, I don't think everyone should do exactly that because it's an experiment, right? But the experiment there is to try to use a well thought out like cognitive ontology to brute force like a central hub of nodes, and that would have some statistical implications for what links the chainer sees, right? But there's a lot of other similar or different experimentations along these lines you could do, and then there's going to be some dependencies we don't understand well between the statistical structure of the atom space and the particulars of the inference control heuristics, right? And I mean that's the big frontier.
Mm-hmm. I agree.
I just have one thing. You said the hyperseed has 100 or so concepts. So there's something called like sumo ontology, but there's a version of it where it's first like they rewrote it. So in Prolog, where it's first order logic, like it's proved and whatnot, and so that already like can be integrated with
Yeah, so I've linked hyperseed in with sumo, and then sumo there's an interesting thing built in sumo called expo, which is the experiment ontology, and I intend to experiment with having machine learning and AI experiments formalized by the system in terms of the expo ontology, right? Because it's just a first order logic formalization of what is an experiment, what is a training data set, what is a run, what is a result, right? So you might as well represent, since that's a bunch of what I'm doing with this hive is AI experiments with different algorithms, like you might as well represent these experiments and the results in the M space using Expo, which is linked to Sumo. So, I mean, Zara and I have worked with Sumo a lot, and you should chat with Zara about that. I mean, there are many logical inconsistencies and problems with Sumo, and we worked a bunch with Adam Pease, who's the author of Sumo. But that would be a whole other meeting. But you should talk to Zara about that sometime. The Hyperseed had a little bit of a different intention because sumo is just it's trying to be like psych minus minus and like trying to formalize all human knowledge in a simple first order logic format, which is kind of interesting. It's not clear to me to what extent it's obviated by LLMs being able to do semantic mapping into logic of any sentence, but it does provide a certain level of standardization. And that is a problem with semantic parsing, is the LLM will sometimes map similar sentences into weirdly different logic forms. So using Sumo to kind of standardize the output of the LLM doing the semantic formalism is useful. But Hyperseed was trying to do something both more dubious and more interesting, which is like try to take a whole theory of life, the universe, and everything, formalize it in higher order paraconsistent logic, then you can try to map everything into this sort of conceptual understanding of things. And so that's why there's 100 to 200 core concepts, and sumo doesn't really have that character, right? So there's a line of thinking in natural language semantics about semantic primitives where people argue there's like 10 or 20 or 50 semantic primitive concepts and everything else can be mapped into those. And sumo doesn't really try to do that. Like sumo treats mind on the same level as cup, right? I mean, it treats walk on the same level as think. Like it doesn't try to isolate which are the really primitive concepts for building a mind versus which are the contingent concepts of a particular environment. And Hyperseed tries to make that distinction, like it embodies a theory of what are the semantic primitives, and it's also formalized in logic, although a richer logic than Sumo uses. Now, you could totally argue let the mind build its own semantic primitives and core ontology on its own. Like don't spoon feed it your philosophy and logic form, and that's also an experiment that should be run. I just personally find it interesting to take my own philosophy of the universe, put it into formal logic, and use it to structure an AI's mind. Because why not? And it is particularly appropriate for a research agent whose job is to carry out research experiments for me, right? Because it's structuring that AI's mind in a way that makes sense for my own research.
You know, it's funny that you say that because it's not a logically like it's not in first order logic, but there's a ontology called Doll's ontology. I'm not sure if you've heard of it, but it's an upper ontology where it's like it tried to go to the very, very primitives, and it's considered like one of the like the most I don't even know how to describe it, but it's like it represents the cognitive it represents concepts cognitively how a human would represent them, and it's very primitive. It's called Doll's ontology.
Send out a link. I'm happy to look at it. Well, this is making me nostalgic. I miss the Aussie accent. So in the mid '90s, I was a professor at UWA in Perth. So we were teaching neural nets and cognitive science and such. So lots of brilliant young Aussies back in the day. I think we have Elijah on this call also, who's in Sydney. You're in Sydney?
Yeah.
In Perth at the moment, actually.
Oh, you're in Perth, I see. You used to
Yeah.
be in Sydney. Yeah.
Yeah, I'm back in Sydney in a bit. I'm actually just down the road from UWA. So,
Yeah. Amazing campus. The main problem there was everyone spent all day windsurfing and playing tennis, and I was socially shunned for sitting in my office coding too much instead of playing sports all day.
yeah, that's about right.
But yeah, I've got to go do domestic stuff, but loads and loads more to discuss here, and happy to continue the discussion of this on Mattermost or in a follow-on session and so forth. And hopefully within some number of weeks rather than too many months, we'll have like the full Omega Hive architecture to play with. And I think this is something the community will be quite enthused about also, and that's the final ingredient I wanted to briefly mention. Like we did already Omega Claw Hackathon and was super interesting, and the thread keeper code that came out of that I've actually managed to use and debug and improve a bit. So we are seeing early signs that we can get some actual traction in an open source development community for this. Both, I mean, there's two ingredients we haven't had before. I mean, one is vibe coding, which just expands the scope of who can viably hack stuff, and the other is having software that actually does something interesting, even with many limitations and very early stage, right? But I mean, between those two ingredients and the popularity of AI and proto AGI, I mean, I'm optimistic that we put open code for this out there, we can get a whole bunch of hives popping up, and I mean, I think we will want something like Moltbook, but less stupid for all the like front men of these agent hives to be collaborating with each other, and then of course ASI Cloud should be a great back end for this, both for the hives themselves and for many of the language models that they reference along with the API calls to frontier models as needed. So there's
Blue
a lot
Sky.
of pieces coming together here.
Yeah, but to say the least, sorry to interrupt, Keller, you raised so many relevant questions in this particular presentations, which touch all of the projects we do at the moment, all of the concepts we deal with at the moment, like all of the product details we're dealing with at the moment. And it's not only about backend, it's about middle layer, like architectural tricks, concepts, design details, and product front end, everything. It's all might be centered on hives. It's totally agreed. It's really relevant. It's very important, and it raises lots of questions of what we need to change or emphasize in our developments.
Yeah, I could
Well-
keep talking a long time, but I've got to go do some summer camp delivery. So
Will you share your deck?
what's that? Yeah, I'll share the deck. Sure. Yeah. Although I've already shared the PDF that it was spawned from, so it's the same content. But for those who prefer decks, I will share the deck a little later this morning.
The PDF is in AI or Hyperon.
Probably, I can't remember. It's too many fucking panels. But
that's-
anyway, I think it might have been on Town Hypercube or something. But in any case, I will share this on the Town Hypercube in a couple hours. So.
It's not as though Mattermost search will help.
No, we were supposed to connect an LLM to Mattermost for better search. I don't know what the hell happened to that. But, yeah.
I don't know what will help, because every point on every slide needs some significant and deep discussion. In fact,
Well, honestly, now that I think about it, Diane's Scout project connected to Mattermost would be very helpful. I mean, the whole thing that does is conceptual clustering of histories of chats, and then navigation of the chats by concept clusters. I mean, that would be helpful alongside actual functioning LLM based search of Mattermost. I mean, we should have both of those, but
There is an
we'll do that.
MCP.
Yeah,
There is a Mattermost MCP for that.
let's plug it in. Yeah.
that
All right.
the internal stuff will work better, because we have 3 types of graphs building from that, and it's just from the backend perspective, it's much better than just having some MCP for LLM driven retrieval. It's just deeper. But anyway,
Thanks, everyone.
Thank you.
Thank you.
Everyone, it was
Yeah.
exciting.